Welcome back, folks, to our little DSO shoot-off here, or shootout. And we got them all set up here. We got a signal going into all of them. It's the same signal going in. I've got it coming from a 50 ohm source. We're going through 50 ohm cable, and it's terminated at this end with 50 ohms. So everything should be really good. Now, normally for these scopes here, they're only 200 kilohertz. I wouldn't have to go through all that trouble. But this one's claiming to work up to 18 megahertz. So with a cable this length, terminating it properly is probably going to be, at least a little bit significant in the final result as to whether or not this meets its bandwidth specification or not. Now this one here is already set up here. We have a 1 volt peak to peak signal going in. It's reading that pretty nicely. We've got exactly 1 kilohertz going into it. Now, some of these are not in the right range to do any kind of measurement at all. This one is. So let's look at this one initially. So we've got Vmax 0.5 volts, Vmin 0.48 volts, the average 0.07 volts, VRMS 0.34 volts, volts peak to peak 0.99 volts. So that's pretty good, and it's coming up with a frequency of 1 kilohertz. If these things are good within 5%, I'm going to be pretty happy with them because they are what they are. They're sub $40 scopes. Duty cycle 49.6% and cycle time 1 milliseconds. This one is okay. It passes its specifications for its measurements. This one here, it's got an auto setup, so let's see how that works. So all 3 of these actually have auto setup. I'm going to have to use it, looks like, on all of them. So let's see what the auto setup does for this one. Give it a chance to go through its little dances. It's taking a bit of time. All right, volts peak to peak is reading 0.9695. Here, let's get this off there. You probably see it a little bit better. I know I will. I don't know if that helps or hinders. I know they're kind of far away from the camera, but I just want to get them all into view at the same time. So yeah, it's within 5%. The frequency is right on. Cycle time is right on. Duty cycle is right on. It's a little bit better than this one. And the Vmax, Vmin are a little bit tighter than this. And V average is better, 0.00 volts. And VRMS is just a tad, a little bit, 0.33 volts. That's good enough. All right, so let's do the auto setup on this one. All right, and we got it's reading exactly the same as this in every way. Yeah. This one has slightly more simplistic user interface because it doesn't have any control over the function generator like this one does. Okay, we'll take that off here too. There we go. That's better. So we'll click auto. Oh, that one was fast. All right, frequency 1 kilohertz, volts peak to peak, 945. So it's not kind of agreeing. It's out by a bit more than 5%. So we'll have to ding this one a point on the measurement accuracy. And now looking at the controls of these things, and this has got a series of 4 tactile switches and a reset, and 3 slide switches. This is for the coupling. This has got a multiplier on it, but it's not really. So if you look at here, this is a 1 volt, 0.1 volts, and 10 millivolts, and these are the 1, 2, and 5. These are indeed attenuator controls here, and should be thought of that way. Now with the other ones here, this one's got mostly just these switches here. It does have a little slide switch to turn it on and off, but everything else is done through these. So if I wanted to go down and change the horizontal, and it'll change within the same ranges that you can get with this, but you have to use the switches over here. Now it does have this one here does have a probe adjustment, so if I press the change button one more time, it'll go I must have gone past it over here, and I can change this to a 10 times or 1 times probe. The same with these 2 here. They're exactly the same in that respect. This one here has a different control for it. So you go into the menu, and then you go down down here to set, and you can see that the probe, you can have X1, X10, or X100, and you select whichever one you want across like that, and then press OK. I really like this method here. What it does do is it leaves the screen relatively uncluttered. It just gives you the information rather than having all the controls there. Now the one really nice thing about this user interface is the fact that any parameter that you have set to manual will come up here. So in this mode here where it says VT, then you could select your different time base, or you can select different attenuations, just like that. So these are the two most important adjustments all the time that people are going to use on an oscilloscope, and they're right there. So the next most important control usually is position on the screen. So that's available in this mode, and you just press up and down, or you can move the horizontal trigger point backwards and forwards. Another nice feature one is in this one, if we go into the menu here and we go to trigger setup, you see that the trigger level can be set automatically or normal. So if we go down here to normal, press OK, and then come out of here, one of the other modes then you have is your trigger levels here. So now if I go up and down, I can set the trigger up and down. This would be my preferred way to use it, is to have that trigger manual. If you go into the menu, you can see all the different things that you can do. So you can set up your measurements here. So you have all those different measurement parameters, and you can select whatever set of parameters you want. Or you can go down here and click on select all. I like the fact that you can select what you need to see without cluttering up your screen. Next mode is the trigger. So you've got your trigger mode, auto, normal, trigger level, auto or manual, and trigger edge, rise or fall. And another thing none of the other ones have here is display control. So you could set persistence is now set to off, but you can set persistence to 1 second or infinity. I know not a lot of adjustment, but it's something, and it's very, very handy. You can also set roll mode on or off, and you can set the display brightness. Even just looking at these screens, this one are comparable. This one is a little bit nicer by the fact that it's bigger, and to my eyes anyway, it is a little bit brighter. Maybe bring them up one by one, a little bit closer to the camera. That's this one. This one here. I don't know if you're seeing too much glare or whatever on it. And then this one here, the bigger screen, it's quite a bit bigger. It says it's only 0.4 inches bigger, but that seems to be quite a bit. That to me is a very clear and easy to read screen. I can read that from 1 meter or 3 feet away without any trouble at all. The other ones I have to kind of bend down and get into them. This one, however, is it's only a 2.4 inch, but the colors are so much richer. And by virtue of the fact that you can get into here and you can go down here, and if you wish, like if you're in a bright room, you can now increase the brightness significantly, or if in your dark room, you can decrease it significantly. So it's great having that control over the display brightness. That's a really nice feature. And let's keep going through the menu in this thing. So here's where you set the probes. You can set the language to 2 Eastern languages. I'm not familiar with the symbols, so I can't really tell you. I think probably one's Chinese, one's Japanese, the other one's English. From here you can enter the calibration mode as well. This one and this one have a built-in calibration. I think this one does too, but this one doesn't. You have to calibrate it with these two things here, and that's not a lot of calibration. But this one's rather extensive calibration. It takes quite a while to do. It takes about, I'd say about 2 minutes to do this one. You have to, of course, have everything disconnected from it, and it will go ahead and calibrate. The next step down here in the menu is the signal generator. So this wins pretty big on the usability of the user interface. It's really nice. It's easy to use. It's intuitive. This thing here, because it's so simple, it's going to get the next highest score. These two are pretty much identical. I think this one has a little bit edge over this one because of all these switches here, and you can just do that easily here with just the little push buttons. But one of the nice features about this user interface is it does have this little thumb switch here for tooling back and forth between the different parameters, and then you just use the up and down arrows to change them. And these switches feel really, really nice. They're not like these little tiny push buttons. they're kind of funky. These are nice and big, easy to hit the right one. So this one is going to come in second in that category. Okay, next thing I want to do is look at bandwidth. Now all of these three here claim a 200 kilohertz bandwidth. So we're going to start raising up the frequency on these to see where they go. Now what we're looking at here, these are all just reading a little bit below the 1.0 volts that they should be reading. So let's look at anything, at the point at which they drop below 0.7 volts. That we'll kind of call that the usable bandwidth on them. So let's first start out by, oh, I must have gone past it. That's one thing I don't like about these user interfaces, that this is a real improvement over. You can't go backwards. So if you go a little bit too far and go past a parameter, you got to go all the way back again. And these two here share that issue. Oh, so this one seems to be losing its ability to trigger. Oh, that's weird. Yeah, so it's not being able to trigger on that for some strange reason. And all set to AC here. Oh, this one's set to DC. Let's set this one to AC, so we're dealing with apples and oranges here. And let's set that. So yeah, it suffers kind of the same problem. It's not being able to trigger unless it gets more than one whole wave in the picture. So it's going to need that in order to be able to trigger properly. So yeah, so it needs to have at least a full cycle in the picture to trigger. This one here doesn't seem to need that, and I doubt this one will too. Get out of the menu, and we'll go to mode BT, and yeah, this one continues to trigger nicely. But we'll try 10 kilohertz and see what that does for us. Okay, this one's nicely set up as it is. We could even go one more step on that, I think. And this one we're going to have to bring it out a little bit more. Same with this one. Okay, so they're all still reading what they're reading for. This 0.97, 0.95, 0.94. I'm going to forgive it. And this one's saying 0.945, exactly what I was saying before. Okay, let's really bring it up here. Let's go up to 50 kilohertz. Now here's an issue with these three here. Their fastest sweep time is 10 microseconds per division. So even here at 50 kilohertz, we're seeing that the wave is getting kind of cramped. Despite the fact that they're still responding properly, they're still getting a reasonable voltage. They're not 3 dB down at all yet. They are getting more difficult to read, whereas you're not going to have a problem with this one. Let's take her up to 100 kilohertz. This one here is at 0.89, so it's beginning to drop down a little bit, 0.88, 0.89, and this is still reading 945. So it's still reading exactly what it was right at the beginning. It hasn't changed a bit. And these ones are starting to droop, but only a little bit. Let's bring it up maybe to 150 kilohertz. No change in the Zeeweii Pro or Zeeweii. This is down to 0.83. 0.81, 0.83. This one seems to be dropping off a little bit quicker than either of these two. So, but right now, of course, all you can see is that it has a waveform. I mean, you could not tell the difference between this and a triangle. And let me see if I can show you that. So we've got a triangle going in. You can tell clearly on this, it just looks the same. So let's go back to our sine wave here. So we've pretty well lost the ability to tell what kind of waveform we have going in. Let's try a square wave. And the Zeeweii, we see a square wave. On these things, we don't. I mean, it just looks like a slightly bent sine wave. Enough of that nonsense. We'll go back to sine wave. And let's take it up to 170 kilohertz. We'll change in the Zeeweii. It's down to 0.8, 0.79, 0.8. Let's go up 10 kilohertz at a time here. 180, 0.79, 0.78, 0.77, 190, 0.77, 0.76, 0.78. No change. 200, 0.76, 0.74, 0.76. All three have met their specifications, so I've got no issue with them. But let's see how much higher we can go. Go up to 210. We're still not 3 dB down yet. 220. We're having a little bit of trouble reading the frequencies accurately at this point. So this one here seems to be, this one's the least accurate. It's bouncing around all over the place. These two here seem to be still pretty good. They're still giving a reasonable approximation of the frequency and the duty cycle. Let's go up to 230. Okay, we're now down 3 dB here. We're down 3 dB here, and we're almost down 3 dB here. These two are still being able to trigger and get the frequency. This one's all over the place. But this one just meets it. These two beat it. Now he's got to test this one. Let's get it up into the megahertz range now. This is supposed to be good up to 18 megahertz. So let's take it up to 5 megahertz and see what happens. And let's do an auto setup on this. Or we could just do this. And we're at 975. So it's absolutely fine up here. Take it up to 10 megahertz. This thing here is doing fine so far. Now that's the limit. We're down to 50 nanoseconds, so we can't really go any further on this. So it's going to get a little bit squeezed as we get up here from 10 megahertz, but it's perfectly fine at 10 megahertz. Again, we're looking for something like 0.701, that neighborhood, once it goes below that. So let's go 15 megahertz. So 0.87, that's fine. Let's go up 1 megahertz at a time. 16. 17 megahertz is still bringing in the frequency just fine. 18 megahertz, we're perfectly okay. One of the reasons this may be okay and other people YouTube reviews haven't been okay is because I see them taking, you know, from a signal generator with 50 ohm output through a 50 ohm cable and then not terminating at the scope with 50 ohms. So at 18 megahertz, you have a meter or 2 meters of cable, you're going to get significant reflections going on in there, and that's going to adversely affect the bandwidth. So in order to do this properly, and you're going directly from a signal generator into the scope, you need to make sure that you've balanced the system out, that you terminate the ends of the cables properly, otherwise you're going to run into havoc. So, okay, it is getting a little bit tight here, and we can see, I don't know if you can see it, but you can see like the little dots showing up. We're going to approach the limits of its 40 megasamples per second. I don't think it's going to go much beyond 18 megahertz. I think once it hits 20, it's going to lose its mind. But let's see if we can go to 19. Okay, it's already beginning to lose its mind. The voltage is okay, and it's being able to read the frequency, but it's running up against its 40 megahertz sampling rate here. So this is approximately half the sampling rate. If we go to 20, yeah. We might even get a little bit more response, better response if we go a little bit beyond that. So in around there. So here we're up to 22 megahertz, and the amplitude's okay, but we're no longer able to read the frequency, of course, because it's sampling at a frequency that's considerably less than half of this. So there's nothing wrong with the analog bandwidth on the front end of this scope. It's pretty good. It's still measuring pretty good up to 26 megahertz here as far as amplitude is concerned. But in all reality, you can't really go beyond this 18 megahertz. Okay, so it is starting to get a tiny little bit jittery, and it's pushing up against its Nyquist point. But it does meet specifications. So they all meet their specifications, so none of them get any special points. Okay, now the vertical accuracy on all of them was pretty good, except for on the Zeeweii here. It was a little bit out, and I put the mark at 5%, so I'm going to stick by that. So each one of these is going to get a 1 because they met the 5%. This didn't quite. I know it was only off by half of 1% beyond that. You have to draw a line somewhere. Horizontal accuracy, they all met their horizontal accuracy, so they met their specifications there. And is there anything else we need to verify? Yeah, the display quality. I'd say this has got the best display quality. Just, you know, out of the box, it's a little bit brighter, the contrast is a little bit better, and you can brighten it up, or you can take the brightness down and darken it up if you're in a dark environment. So this definitely got the edge on display quality. And this is next. It's just bigger. I mean, it's not really any brighter than these other two, but it's bigger and more legible. So I'm going to give this a 2, a 1, a 0, and a 0. This one has variable persistence and brightness control that the other ones don't have, so it gets a point for each one of those, and that's it. So now I did want to show you, some little bonus time on this. It's not going to get any extra score for it, but I wanted to kind of hook up a probe to it and show you what the function generator is capable of on this. Okay, I decided I would just go ahead and use itself to look at itself. I have the function generator set up for 1 kilohertz square wave, and I'm going to use that to adjust the probe here and just compensate it. Okay, that looks good. Let's get into signal generator here. Yeah, okay. And let's bring up the frequency a little bit. We get up into the 100 kilohertz range here. Okay, now let's come out of the menu. Let's do an auto setup. Bang, that's pretty good. And mode, I want to, let's see what it can go up to here. So we're going to go in here. Now the specifications, butterfingers, specifications say it'll go up to 500 kilohertz. So let's see what'll happen. So if we go up to 200, 300, 400, let's have a look at this waveform here. It's still looking pretty good. I mean, you're losing a little bit on the leading edges. Yeah, let's go up some more. 500, 600, 700, 800. Now the square wave is looking a little bit less like a square wave at this point, but still identifiable as such, although you really couldn't use it for a lot of things you'd use the square wave for. So let's go over now, we'll switch into one of the other waveforms like a sine, see how that looks. So use the auto button here to do that. There's a triangle, there's a ramp. Ramp's kind of edgy. Now mind you, they're not claiming 800 kilohertz at all for the ramp. I think they're claiming 20 kilohertz for that. This is the half wave rectification. Let's see, have a better look at that. Bring it down a little bit here so we can put it in view. That's a nice feature, the way you get to adjust these things by clicking on the mode. That's very nice. Now let's also look at a full wave. So that's the next one. So that's supposed to be a full wave. And let me bring that up now a little bit. So this would look a little bit more like a full wave at a lower frequency. Like we're really stretching the frequency capabilities of this function generator with these non-sinusoidal waveforms. So if we were to bring that down, let's say we brought it down to 100 kilohertz again, it's going to look much more like yeah, we want to get into it. Yeah, so that looking very much more like what you want to see. Handy little function generator. So now let's go and do something fancier. Let's go in and do the cardioid waveform here and see how fast we can get that going. So let's bring that up. 900. Let's go over here. See if we can kick that up into the full 1 megahertz. There we go. And oh, that's not the one I want to adjust. Bring that back over here. Yeah, still looking fine. So it's a semi-sinusoidal with just amplitude changes in the middle of it. So let's go now and look at noise. And that does indeed look like noise. And let's cycle over then to the sinusoidal waveform. Get our position back up again. And that's it. There we are, 1 megahertz. And it's doing fine. So we can go back into the menu here. We can go up to our measurement and we can ask it to look at frequency, and it's coming up at 1 megahertz. It exceeds specifications. I don't know if the specifications put in the manual were old and this has got an updated firmware or something like that in it. But it certainly has the capability to go up to 1 megahertz with all the waveforms. But I think that only really makes a lot of sense with the closer to sinusoidal ones like the cardioid and the sine wave itself. So one thing I did want to show you before I leave here was the single shot mode and memory capture. Now I tried to contact Zeeweii about it, or Zeeweii, or whatever the name is, and they never responded to me, but it didn't come with any specifications for amount of memory. But as you can see here, I'm looking at about 5 microseconds across the screen here. We could take a single shot. And the way you do that is by pressing the power button. So the little power button here, just a really quick press, and that'll take a snapshot of it. But here's the interesting thing. I can now look at my signal. So I do have the ability to go in there and capture, I don't know how many points. It looks like there's quite a substantial number of points though. And if I change the mode here to be able to guide it, I can go back and forth in it. I can look at all the waveform that has been captured. So it is truly a digital storage oscilloscope. I just wish I knew what the number of points that it captures is, because that's pretty handy. It's a real selling point. They don't publicize it. So here's a good indication. Like, this was the noise. You can see that the noise is not really noise. It's just a noise-like waveform. All right, folks, let's go upstairs and tally up the score. Okay, so here we are. So once we tabulate everything, this is the final score that we get. The original DSO138 gets 11. The FNIRSI 138Pro gets 16. The FNIRSI 152 gets 23, and the Zeeweii 154Pro gets 37. Certain categories here where I really would like to give it a little bit more, but I have to kind of follow the weighting scale that I started out with in order to be fair. Yeah, so that's it, guys. Thanks for joining me in all this. If you have any questions about any of the categories or anything else that I did here, just let me know. I'll try to explain to you. But I think everything is pretty self-evident here. I think I put enough notes in here to try and give you some idea of why I scored things the way I did. And by all means, I mean, if some of these categories are more important to you than other ones, like you may not care that the documentation only is a single sheet and it's only in one language. So just discount this category altogether and then reevaluate the spreadsheet. So I'm going to take the spreadsheet, I'm going to put a link to it below, and feel free to download it, go through it, adjust it according to your own preferences. But at least it gives you some information that I was able to test for you that you wouldn't be able to do yourself unless you had the thing in your hands. So at least that's all been done for you. Well, thanks for joining for this little series. It's not a big winner as far as getting a lot of views and view time, but I found it very interesting, and I hope you guys got something out of it too. So we'll see you in the next video. For my Canadian friends, it's Thanksgiving weekend. Enjoy it. And from all the other people around the world, have a great weekend. Bye-bye.